Assalamualaikum and hi. Last week we have learned about the chapter 5 gravity retaining wall on the lateral forces that acting on at the face of the wall. For example, we have wind pressure, liquid pressure and also pressure from the granular materials such as soil lah. This week kita akan sambung lagi chapter 5 ni, but we will look into the stability calculation. Mostly final examination question mostly akan keluar pasal stability calculation ni, so you have to focus on this one. A retaining wall is said to be stable if a limit state set out are not exceeded. As you see sebabkan dia ada limit state yang I ajar the masa last week. Ada limit state sebab dia ada 5 failure criteria, sliding, overturning, bearing pressure and such. Ada 5. Jadi kita akan tengok what we have to look at one by one, so that we must make sure that those limit state not being exceeded lah. If they exceed, dia akan fail. Therefore, a number of calculation must be made as follows. Calculation weight and lateral thrust. One thing, kita kena kira weight of the wall because kita nak calculate downward acting force. Maksudnya the gravity itself campur dengan mass of the wall yang akan stabilizekan the retaining wall. And lateral thrust ni, so lateral thrust ni meaning forces yang acting at the back of the wall tu lah, whether it is wind, whether it is liquid or whether it is granular materials. You have to determine the position of the ground reaction, which means that because of those forces acting on the wall, jadi daripada combination of forces acting downward and forces acting ke face of the wall tu, dua-dua forces tu akan ada total forces lah. Maksudnya forces semua sekali kat mana sebenarnya position dia yang akan acting dekat ground tu sendiri. Forces tu yang akan maybe menyebabkan wall tu akan overturn, wall tu akan tenggelam dan sebagainya. Jadi kita kena tengok kat mana position on the ground reaction. And then determine the ground bearing pressure. So you must make sure that the allowable bearing pressure not being exceeded. Kalau exceed, ground tu akan collapse, which means dia akan bring you punya retaining wall collapse jugalah. Determine the factor of safety against overturning. So kita kena tengok on overturning punya calculation, whether retaining wall tu akan flip, overturn, terpusing atau tak. And then determine the factor of safety against sliding. So whether the friction provided dekat ground tu, is it enough to make sure that the retaining wall will be static, will not be sliding. So this is the determination of the position of ground reaction. As you can see, you akan kena calculate ni semua. Okay, meaning the total weight of the wall lah, because of this wall rupa dia macam ni. Dia punya cross section of the wall is like this. So kalau you nak kira area, it is much easier for you untuk divide dia into 2 different area. So you akan kira area 1 dan area 2, berapa berat on each area. So that's why ada W1 and W2. And then another thing is another forces yang acting, lateral forces this one, lateral thrust. So you have PA, whether it is liquid or whether it is granular material or wind pressure. Jadi kita kena kira on this force juga. Kita nak cari daripada these two forces, maksudnya one daripada the weight of the wall itself and another one daripada lateral forces. Combination of those two, dekat mana sebenarnya ground reaction dia, whether it is here. Maksudnya forces tu akan, bila you combine dua-dua, dia akan jadi macam ni kan. And then bila ground tu dia akan react, macam you belajar reaction lah masa part 1. You belajar pasal, you buat SFD, BMD, you belajar yang RA, RB reaction. So that is ground reaction. Kat mana sebenarnya reaction yang nak jadikan dia equilibrium, because of whatever pushing down must be pushing up also. Jadi kat mana sebenarnya that force. Kalau yang this one, this is step type of retaining wall. This step type, okay, as you see, you have because you nak kira area, so it is much easier you kira for one area retaining wall you than this one. Jadi this is the retaining wall, divide into 2, so W1 and W2. Since you have another area dekat sini untuk kira for weight, walaupun dia soil, but this soil actually help to stabilize the retaining wall sebab berat soil ni dia sit on the base of this retaining wall, so it helps to stabilize. Jadi that's why ada W3 dekat sini. So this is for the step type of retaining wall. If let's say there is a soil dekat belakang ni, tolong sekali to stabilize the retaining wall, so we consider it as the weight of the wall also. So the position of the ground reaction, okay, this is the formula you need to memorize. X ni position ground of ground reaction from B. So where is B? So basically, as you know, sebelum ni ada bagi tahu juga, you have toe and heel. Okay, if let's say the retained materials is at the back of the wall like this, so this is soil for example. A is here, so A is at toe and heel is at B. Jadi kita akan kira position of ground reaction daripada B. So kat mana sebenarnya lah, from all the forces yang acting here combine together, dia akan going down like this. So kat mana sebenarnya position dia daripada point B, berapa meter daripada sini. Formula dia B minus B ni adalah base length, which means this one lah, this is B. Kalau 3 meter then it is 3 meter. And then you have total moment O, total overturning moment, which is forces yang mana yang akan overturnkan this retaining wall, which means lateral forces ni lah yang menyebabkan retaining wall you akan overturn. So you akan kira moment that caused by this force. Daripada soil ni dia akan hasilkan moment, so berapa moment dia, so itu adalah total overturning moment. You have total stabilizing moment. Jadi yang help to stabilize the retaining wall is, one is this retaining wall ni punya weight sendiri, and another one is, kalau katakan this is step soil, so ini pun termasuk juga soil yang sit on top of the retaining wall pun akan help to stabilize. Jadi moment from these two forces yang akan help to stabilize retaining wall, ini yang kita kira. You dividekan with total vertical forces. So total vertical forces adalah this one lah, which is vertical forces, vertical stabilizing forces lah. Okay, yang vertical. Ini horizontal. Lateral thrust, lateral forces, dia semua horizontal. Soil, liquid, wind, semua dia adalah horizontal forces. And vertical forces is force yang going downwards ataupun upwards. Kan like this. This is, we call it horizontal. If something like this and like this, we call it as vertical. So this is vertical forces. When we find the position of ground reaction, we need to calculate the ground bearing pressure. Kita nak tahu berapa sebenarnya ground pressure dekat retaining wall yang dihasilkan daripada forces acting on the retaining wall, so that kita tahu whether the ground can support the retaining wall or not. Kat mana-mana pun tanah ni dia ada maximum pressure dia boleh support. So we must look at berapa sebenarnya maximum, so that whatever that acting on the retaining wall tak exceed that value. So that's why kita cari this ground bearing pressure. This is the formula. This is the one. Q A/B equal to V over B V over B plus minus 6VE over B square. Apa maksud slash ni? Meaning that if you see that QA, it means that V over B plus 6VE over B square. And QB is V over B minus 6VE over B square. V here means the resultant ground reaction, ataupun dia adalah kiranya total vertical forces, which is yang kalau you tengok dalam previous formula, we also call it as RV. This one total RV ni lah total vertical forces. V tu pun adalah benda yang sama, vertical forces juga. But here we call it as total resultant ground reaction. Sama je total vertical forces. Over B, so B is the base length. How much is dia punya panjang dia. Plus minus, so 6V ni benda yang sama. So E ni adalah eccentricity. If you have this kind of retaining wall, so you dah cari berapa value X, which is the position of the ground reaction. Okay. For example, position of the ground reaction dekat sini. So this is X. Okay, position of the ground reaction. Dekat mana sebenarnya ground reaction dia punya centroid dia dekat mana You dah dapat. You akan kira, for example, you ada retaining wall like 3 meter 3 meter length dia punya base ni. Okay, jadi 3 meter daripada sini this is 1.5 meter because of you just bagi 2 je dapat dia punya betul-betul dekat tengah daripada 3 meter ni. E ni adalah eccentricity ni is this one. Berapa beza X ni dengan setengah daripada B. So senang cerita, E is X minus B over 2. Jadi you bagi 2 berapa jarak base. Kalau kata 3 meter divide by 2, then it is 1.5. So X minus 1.5. You akan dapat berapa value eccentricity. Divide by B square. So B square ni adalah base length. So that's the formula for the ground bearing pressure. There is another condition for ground bearing pressure. We look at the middle third rule. Bila you kira ground bearing pressure, dia based on middle third rule ni. Formula mana you nak pakai? Because if you see here kat sini pun ada another formula for ground bearing pressure. You nampak huruf Q ni, you tahu this is ground bearing pressure punya formula. Formula yang ni walaupun nampak ada 2 value, dia boleh pakai mana-mana lah between these two. Jawapan you akan sama. Tak ada masalah. But from these two, you ada formula yang sebelum ni juga. So you nak tentukan whether you nak pakai this formula, ground bearing pressure QA/B ni, ataupun you nak pakai this formula. Dia based on middle third rule. QB dia adalah kosong. Value QB dia memang kosong. So because you dah kira X equal to berapa. For example here, I buat this kind of retaining wall. So you have to divide kan dia into 3. Okay. I punya contoh ni base dia 3 meter. So you divide dia. Sini start daripada B. Ini A, ini B. Adalah kosong. 1 meter, 2 meter, 3 meter. Position of ground reaction which is X equal to 1.6 meter. Okay, which means the within the middle third. Termasuk masih lagi dalam middle third. Middle third tu dekat mana? Yang ini. Whatever number inside here, dia adalah middle third. Dalam antara tengah-tengah ni. You dah bagi 3, yang duduk dekat tengah-tengah ni adalah middle third. So if let's say you dapat 1.6, dia masih lagi between 1 meter ke 2 meter. Maksudnya dia masih lagi middle third. So when it is still inside the middle third, you akan pakai formula yang dekat belakang ni. Okay. This formula is if it's inside middle third. However, if you dapat bukan 1.6, contohnya I bagi X equal to 2.1 meter. It is already outside. Dia dah exit, dia dah duduk dekat sini lebih kurang. Jadi, dia dah keluar daripada middle third. You have to use this formula. Okay, if let's say X is equal to 2.1 outside middle third, you akan pakai this formula to calculate the ground bearing pressure. Formula for overturning, FOV. So F ni, it means that factor of safety against overturning equal to stabilizing moment divided by overturning moment. You kena kira moment yang dihasilkan daripada vertical forces, you akan dividekan dengan moment yang dihasilkan oleh lateral forces ataupun horizontal forces. Another one we have sliding. Factor of safety against sliding is equal to mu. This one we call it as mu V over P. Mu ni equal to tangent delta. Delta ni adalah angle of wall friction. Kat bawah ni kan ada friction, which is what we call as RS lah. Okay, so friction. Dia dihasilkan daripada angle of wall friction ni lah. Friction daripada wall ni dia menghasilkan, dia bertemu dengan ground, dia akan menghasilkan friction. Formula dia sebenarnya adalah Fs sama dengan Rs divide by P. Rs ni adalah friction. So friction ni adalah bersamaan dengan mu darab dengan V. Okay, so itu sebenarnya formula ni, nampak. Example 7, sebab last week kita sampai example 6. The masonry dam whose cross section is shown in the figure retains water against its vertical face. Examine the stability condition of the dam with respect to tension in the joints, ground bearing pressure, overturning and sliding. This question minta you check dia punya stability condition. Tapi on the certain things, it suruh tengok tension in the joints, ground bearing pressure and overturning and sliding. Tu saja ada 1, 2, 3, 4 benda dia minta. The unit weight of the masonry is 21.6 kN per meter cube. So ini adalah unit weight of the wall lah, ataupun masonry tu sendiri. And angle of wall friction is 30 degrees. Jadi wall friction, which means delta tu adalah 30 darjah. As you see, bila you nampak je perkataan like kena examine stability condition. So obviously you kena dapatkan forces, you kena dapatkan berapa moment. So forces you ada 2 types, which is one is horizontal and one is vertical. So daripada those 2 vertical and horizontal forces, you have to find the moment that dihasilkan oleh these 2 forces. I buat dulu for vertical forces. So here I bahagikan into 2 lah. So vertical forces, as we can see, you punya retaining wall rupa dia macam ni. Is better if I divide it into these 2 area, 1 and 2. Dia bagi kat sini, the unit weight of the masonry is 21.6 kN per meter cube. Maksudnya 1 meter cube of this masonry wall, dia punya weight dia adalah 21.6 kN. So that's why kita nak cari berapa sebenarnya dia punya volume dia lah. Kita cari berapa area dia. Obviously it is half darab dengan berapa panjang this one. So 2.7 minus 0.9. So from here to here, this is 1.8 meter. Jadi darab 1.8 meter darab dengan height dia 4.2 meter. So kalau kita nak dapatkan volume, should be kita akan darab berapa panjang dia punya panjang ke sana lah kan. But we don't know and we don't really care what is the value. Jadi kita abaikan that calculation. Kita ambil je area dia berapa, and then kita darab je dengan 21.6 kN per meter cube. So kita akan dapat dalam unit kilonewton per meter lah. Sebab kita tak ada satu lagi, which is the panjang of the wall tu, berapa dia punya total length of the wall akan dapat jawapan for the first area. And for the second area, okay, it is 0.9 darab dengan berapa petak ni punya area lah. So 0.9 times 4.2 darab dengan dia punya unit weight. That one is for area number 2. Okay, I dah buat. Okay, so this is for the first area. And then for the second area, this is for the second area. So here I put W1 and W2, maksudnya weight of the wall 1 and weight of the wall 2 lah. Dapatkan berapa area you darab. So ini adalah area tadi, calculation area, and then ini adalah dia punya unit weight tadi. Kita nak dapatkan moment bila kita dapat forces kena darab dengan distance. So ini adalah force, ini adalah distance. So kita akan dapat moment. Take moment daripada A. Okay, so A ni apa? A tu toe lah. Here, this is A. Daripada sini. So kalau you bahagi ni dua, this W1, W2. So kita akan kira satu-satu. So kat mana forces dia? Because of bila weight ni, dia punya force turun ke bawah. Okay. Jadi distance dia mesti yang this one Dia mesti distance dia 90 darjah daripada direction of the force. So force tu going down. Ini adalah distance dia 90 darjah. So berapa jarak ini? So itu yang you kena carilah. So force darab dengan distance. Jadi kalau you have this kind of segitiga, you know that kalau you nak dapatkan jarak ni adalah 2/3 B. Kat sini ada 1/3 B kan, berapa dia punya B ni. Kalau panjang ini adalah 1.8 Tadi kita dah kira kan, dia punya lebar segitiga tu adalah 1.8. Maksudnya 2/3 daripada 1.8. Jadi I dapat 1.2 meter. Calculate the moment. You just simply darabkan je forces berapa, 81.648 ni. Darabkan dengan this 1.2 meter, the distance daripada A ni. So you akan dapat berapa moment dia, which is 97.978. For weight of the wall number 2, which is kalau you tengok kat sini, this one I ada buat satu lagi sebenarnya. Okay, so W2 here sama juga because of tadi dah kira area dia kan, which is 0.9 times 4.2 darab dengan 21.6, the unit weight of the wall. Kena kira dia punya distance, okay, daripada A, which is here L2 ni lah. L2 ni 0.9, you dah ada distance from here to here, it is 0.9 meter this one. So 0.9 bahagi 2, so you akan dapat 0.45. You pluskan dengan balance ni lah, which is 1.8 kan. This is 1.8 meter. So 0.45 plus 1.8 meter, you akan dapat distance daripada centroid W2 pergi ke point A. Inilah dia setengah daripada 0.9 campur 1.8 dapat 2.25. To get the moment, just simply darab 2.25 with 81.648. You will get this 183.708. You have to calculate the total vertical forces, which is total RV. It is 163.296. Campurkan je these two forces. For total stabilizing moment, so this is stabilizing moment because the wall itself yang help to stabilize the retaining wall. The weight itself, you just campurkan je these two moment, you will get the value. The next is we need to find for the horizontal forces. But first we need to look at balik apa sebenarnya horizontal forces here, which ataupun lateral forces kat sini So the masonry dam, so it is a dam, so it retains water. Okay, jadi bila dia retain water, you should know what is the formula. This is pressure distribution for water. So as you masih ingat, okay, berapa sebenarnya value dekat bawah ni? Formula. So unit weight of water darab dengan H. So ini sebenarnya value point ni. Daripada atas ni kosong lah kan. So sini semua kosong. So berapa value kat sini? Sebab dia increase uniformly. Semakin ke dalam dia increase uniformly. Unit weight of water kena hafal 9.81 darab dengan H. You nak kira total berapa sebenarnya pressure untuk semua ni, untuk kedalaman 4.2. Jadi kalau you kira area dia setengah darab panjang, kalau you kira untuk area segitiga kan. Okay, so berapa value dekat sini, berapa panjang ni lah. Senang cerita selalu you kira macam tu kan. So kalau kat sini kosong, so inilah dia punya berapa value dia kan. And then you darab dengan dia punya H. Panjang darab lebar, darab setengah So inilah dia macam mana you nak kira for water. We call it SPA, which is the active lateral pressure. Setengah darab dengan unit weight of water darab H darab dengan H. So since H dia sama, which is 4.2 meter, so 4.2 power of 2 lah. That's why I put here 4.2 power of 2. So you akan dapat 86.524. We need to look at the level arm from A. Sebab apa-apa kita akan ambil distance, sebab kita nak kira moment kan. We look again here. So kat mana distance dia? So ini horizontal forces. Bila horizontal forces, dia akan act like this daripada dia punya centroid. Kita nak tahu berapa jarak ni. So it is H over 3 lah, sebab you nak dapat ke point A. Jadi jarak dia mesti 90 darjah, sebab forces kan dia macam pusing. Dan dia nak jadi moment kan dia like this Okay, dia takkan pusing macam ni Dia takkan ni tak ada Dia takkan lalu jalan jauh, dekat je. So like this. So berapa sebenarnya jarak ini? So you nak dapatkan distance mesti 90 darjah daripada force tu lah. H over 3. H tu maksudnya height of the water tu lah. So water tu memang sampai top of the wall. Jadi H bahagi je dengan 3. Sebab kalau daripada top ke sini, kalau you tengok segitiga kan, right. So kalau daripada centroid dia, okay, ni 1 over 3. Mesti atas ni 2 over 3. Ni 1 over 3. Ni 2 over 3. Like that Kalau dia terbalik sekalipun, kalau macam ni, this is 1 over 3. This is 2 over 3. This is 1 over 3. And this is 2 over 3. Please remember pasal centroid ni, sebab you dah belajar daripada sekolah lagi, if I'm not mistaken. So 1 over 3 darab dengan 4.2 meter. Okay, 4.2 meter ni H dia lah. Dia akan dapat 1.4. So calculate the moment. Force darab saja dengan the distance. Then you get 1 to 1.134. Because this is the only forces that act. Force that act on the retaining wall. Tak ada force lain, just a liquid pressure. The total is the same value We need to answer what else the question want you to calculate. Dia nak minta you calculate tension in the joints, ground bearing pressure, overturning and sliding. Kita tengok formula, kita nak kira dulu kat mana sebenarnya position of ground reaction. Sebab kalau nak check dia punya tension in the joints, you kena dapatkan position of ground reaction. And also kalau you nak calculate ground bearing pressure pun, you perlukan that position of ground reaction Gunakan formula X equal to B minus, because kita nak kira position of ground reaction. Ini formula Check balik formula you tadi. Masukkan apa yang kita dapat. Since kita punya retaining wall, dia punya width dia adalah 2.7 meter, ataupun base dia 2.7 meter, minus dengan total stabilizing moment. Total stabilizing moment you dah ada kat sini. 281.686 minus with total overturning moment. Tengok balik kat sini. So total overturning moment is 121.134. Dividekan dengan total vertical forces, which is 163.296. Okay, ini dia lah. Okay, total vertical forces. Calculate, you dapat 1.717 from B, meter from B. Jadi kita nak tengok dia pakai dia within middle third ataupun outside middle third. The retaining wall itself rupa dia macam ni. Okay. Distance dia punya base dia adalah 2.7 meter. Divide dia into 3 section, right? Start from 0, 0.9, 1.8 and hujung sekali 2.7 meter. You dapat X adalah 1.717, which means it is around this area, 1.717, around this area lah, kat sini. Masih lagi dalam middle third Since the base is 2.7 meter wide, its middle third lies between 0.9 to 1.8 meter lah. The resultant force RV cuts inside middle third, masih lagi berada dalam middle third itself, 0.9 ke 1.8. Hence no tension will develop in the joint. Jadi tak ada tension yang akan develop dekat dalam joint ni. No tension in the joints. Kita dah check for the first question. We need to calculate juga untuk dia punya ground bearing pressure, because the question asks you to calculate the ground bearing pressure. Since dia punya middle, dia punya X, okay, which is the position of ground bearing pressure, is within middle third. So you know the formula untuk kira ground bearing pressure. Jadi formula dia you akan pakai QA/B ni. Sebab masih lagi dalam middle third, this is the formula yang you have to use. V over B plus minus 6VE over B square. Masukkan je formula, dalam formula, the value of V and everything. So V ni pun you boleh check, sediasa check lah berapa value yang you dah dapat dekat dalam calculation this one. Masukkan saja total vertical forces 163.296. Okay, ini dia. You dividekan dengan B, which is 2.7 meter, the base, plus minus 6V, masukkan V lagi. So eccentricity ni X minus dengan B divide by 2. Jadi X you dapat 1.717. You minus je dengan 2.7 divide by 2. You akan dapat value ni lah, 0.36367 ni. So itu adalah E, eccentricity. And then divide by B square. So you akan, masa you kira ni 60.48 ni adalah calculation for this one. Better you calculate macam ni lah. You calculate asing-asing like this. Okay, so plus you akan kira for QA. Kalau you minus ni, you tolak value ni, you akan kira for QB, distribution of bearing pressure sebenarnya, ground pressure. So mana A? So ini A, ini B. A tu adalah 109.8. So kalau B tu adalah 11.155 kilonewton per meter square, value kat sini and here adalah 109.805. Pressure dia going down like this. So this is ground bearing pressure. The next thing in the question asks you to find the overturning and sliding. Okay, ini adalah calculation for overturning and this one for sliding. For overturning, you use the formula of total stabilizing moment divide by total overturning moment. You dah adalah stabilizing moment inside this one. right? So overturning moment is 121.134 and stabilizing moment is 281.686. Masukkan je dalam that formula. You dapat macam ni lah, 2.325. Okay, so stabilizing moment divide by overturning moment. And then you kira for sliding. Formula is mu RV divided by P. So mu, you need to find the value of mu. So mu given in the question, okay, dia dah bagi the delta, which is the angle of wall friction, 30 darjah. Jadi tangent 30 darjah, you akan dapat 0.577. You darab dengan total vertical forces, which is 163.296. Kat sini ya, 163.296 bahagikan dengan P ni adalah, biasa kira PA tu kan, lateral force, active earth pressure ataupun lateral force. Jadi divide je dengan total horizontal force. So P 86.524, you akan dapat 1.089. So dapat value-value ni semua, you tak perlu nak compare dengan apa-apa pun, sebab usually kalau dalam soalan dia akan bagi like some values, what is the acceptable factor of safety. So kalau you dapat kurang daripada value given, meaning that akan fail lah. Okay, jadi mesti minimum dia adalah, for example like the given for factor of safety against overturning, yang selamat adalah 2.5, then you dapat 2.35, so dia kurang daripada 2.5, meaning dia not safe. Okay, ini contoh sajalah. Okay, dalam next example we will look at this. Okay, tapi dalam example ni dia tak suruh you compare dengan anything. This is the only answer yang you have to jawab lah. Now we look at example 8. Figure shows reinforced concrete retaining wall which support a cohesionless soil having the following properties. Given a unit weight of soil is 19.8, angle of shearing resistance is 30 degrees, meaning angle of shearing resistance tu theta lah, 30 darjah. Unit weight of concrete is 24.5. This is the unit weight of retaining wall itself. Check the stability of the wall satisfying the following design. Okay, ini yang saya cakap, dia ada minta you check, make sure that factor of safety against overturning mesti lebih daripada 25. Maksudnya dia ada limit dia, maksimum dan juga minimum kat sini. Jadi you akan comparekan jawapan you. Kalau katakan you dapat factor of safety against overturning lebih daripada 2.5, meaning dia akan safe lah. Kalau you dapat 2.1, meaning dia tak safe. Kat belakang ni it retain soil. So here it is soil. And this is the cross section of the retaining wall. What we need to do as usual, bila kita kira, mesti kita akan kira forces and kira juga dia punya moment. Vertical forces and also horizontal forces. So vertical forces going down like this, and horizontal forces is the lateral force come from the soil. Kita akan buat table. Okay, first kita akan tengok on the vertical dulu, baru kita akan kira for horizontal. So for vertical, okay, ni adalah cross section. I divide kan, this is W1. Okay, I divide kan macam ni lah, W1. Okay, so W1 kira area dia lagi 0.5 darab 7.5. So W1 0.5 darab 7.5. Okay, ini adalah unit weight of concrete ataupun unit weight of retaining wall itself. So ini area dia, and this is unit weight of concrete ataupun retaining wall. You dapatlah dia punya W1 punya force. And the next one, kita terus kira dia punya lever arm from A. So lever arm from A, okay, L1 ya. So berapa distance daripada centroid of W1 pergi ke A. So A at this point lah. So 0.5 divided by 2. plus 1.1. Sebab you nak dapatkan berapa distance ni plus dengan distance yang this one kan. Jadi 1.1 lah kat sini. And 0.5 is 0.25 plus dengan 1.1. You akan dapat K setengah darab 0.5 campur 1.1, 1.35. And then dapatkan moment darab je 91.75 darab 1.35, you akan dapat value moment dia. Kita akan kira for W2. For W2, so bawah ni I call it as W2. Okay, for W2 sama juga, dapatkan dia punya area. The area is 2 campur 0.5 campur 1.1 ni, you akan dapat 3.6 lah. So this is total dia 3.6 darab dengan 1 meter. And then you just darab je dengan dia punya unit weight of concrete. And this is the answer. And the lever arm from A, separuh daripada ini 3.6 bahagi 2 je lah, because of kat situ lah dia punya centroid. You akan nampak kat sini I dah tulis separuh, so centroid 3.6, you just divide dengan 2, you akan dapat dia punya distance. Okay, you dapat 1.8 darab je 8.82 darab 1.8, and this is the moment. And then another thing that we must have a look here, akan ada lagi satu which is what we call as WS1, weight of soil 1. As what I mentioned sebelum ni, bila ada soil sit on the base of the retaining wall, it will also help to stabilize this retaining wall. Jadi weight of soil ni pun termasuk Jadi kita kira area WS1 ni 2 meter times with 7.1. Okay, sebab dari atas 7.5, daripada atas ni sampai ke sini 7.5, you kena tolak 0.4 sebab soil ni tak sampai top of the retaining wall pun. So here it is 7.1. So 2 times 7.1, right? And then 19.8 ni adalah unit weight of the soil, sebab itu adalah berat soil. Kalau you tengok dalam soalan, berat soil adalah 19.8. Okay, jadi kena darab dengan unit weight of soil itself. Untuk dapatkan dia punya lever arm, okay, so lever arm daripada centroid dia, so centroid WS1 ni dekat mana? Dekat tengah-tengah ni lah. Jadi berapa distance dia as shown macam L3 ni. So 2 meter bahagi 2, so you akan dapat balance kat sini 1 meter, and then you ada another 1.6 meter dekat sini. So it is 2.6 meter 2 meter bagi 2 campur 1.6 ni Okay, 2.6. Darabkan, you akan dapat moment. So itu saja on the vertical forces and moment. Campurkan untuk dapatkan total vertical forces and dapatkan total stabilizing moment. Okay, and then kita akan buat for horizontal forces. For horizontal forces, we know that this is what we call soil. Bila dia adalah soil, kita kena dapatkan KA ni. Okay, ataupun dalam Rankine theory tu, sebab ini adalah pressure due to granular material. If you still remember this formula, KA equal to 1 minus sin theta plus sin theta. Pakai this formula, masukkan je, because of kita dah tahu value theta kita adalah 30 darjah as what given in the question, right? And then you kira dapat 1/3 ataupun 0.333. Make sure it is 3 decimal places. Jawapan dia mungkin akan ada sikit lebih kurang lain sikit lah, tapi almost sama Okay, this is pressure distribution for granular material ataupun untuk soil. Dia uniformly increase as the depth is increase. Semakin ke dalam dia akan semakin naik lah dia punya pressure. So berapa value dekat point ni? Value dekat point ni adalah Ka unit weight of soil darab dengan H. So ini adalah value kat sini. So ini kosong. Jadi bila kita nak kira berapa total area dia, maksud total pressure distribution, kita akan kira area. So setengah, which is area triangle ni, darab dengan dia punya lebar, which is Ka unit weight of soil H, and then kita kena darab dengan H, which is the height setengah darab lebar darab tinggi. So ini dia punya B lah kononnya, ini adalah dia punya H kan. Okay, setengah darab lebar darab tinggi. So ini formula to calculate pressure due to granular material. So PA maksudnya active lateral pressure ni lah. It is 1/2. Ini adalah Ka, and then unit weight of soil, right? And then darab H, and then kena darab H. Jadi H kuasa 2 lah. Ka ni kita dah tahu dah tadi 1/3 sebab kita dah kira dekat this one. Okay, so kita dah tahu it is 1/3. Unit weight of soil, so ini dalam based on the question. So kalau you tengok 19.8 adalah unit weight of soil. 8.1 ni adalah height of soil. Kenapa bukan 7.1 Sebab tadi masa kita kira area ada kita pakai WS1 ni 7.1. So height of soil ke bottom of retaining wall. So if you see here, height of soil nak sampai ke bawah retaining wall ni adalah, so ini 7.5 sampai kat sini 7.5, and then tolak 0.4 kat sini sebenarnya adalah 7.1. Tapi sampai bottom of retaining wall, maksudnya sampai sini you kena tambah lagi 1 meter. So dia adalah 8.1. Itulah height of soil sampai bottom of retaining wall. So it is 8.1. So H darab H maksudnya 8.1 darab 8.1 lah, ataupun 8.1 kuasa 2. So that is 216.513. And then we need to calculate the distance, level arm from A. To calculate the distance, we must know how the pressure distribution look like. So this is the pressure distribution. Jadi daripada centroid dia dekat sini, okay, jadi dia adalah horizontal forces. Jadi distance dia adalah yang 90 darjah ni. Maksudnya H/3 ni ataupun 1/3 darab H. H here it is 8.1 lah, which means the height of the soil. Mesti dari atas ni sampai bottom of retaining wall. So 8.1 darab dengan 1/3. And then you dapat 2.7, darabkan je dengan the force, and then 584.585. So that's it. We don't have any other horizontal forces acted on the face of retaining wall. Ada satu ni je. That is the total lah. So that is total horizontal forces, and that is total overturning moment. As what given in the question, okay, kita nak kena cari check stability against overturning, sliding and maximum base pressure. So usually what we do, normally kita akan terus cari dia punya X lah, sebab kalau kita nak kira base pressure ataupun bearing pressure ni, kita memang kena kira dapatkan dia punya position of ground reaction. Nak kira dapatkan dia punya position of ground reaction, formula ni lah. Okay, so 3.6 is the base width, 3.6 meter. Okay, ambil saja value of stabilizing moment and overturning moment daripada this jadual ni. So stabilizing moment is this one and overturning is this one. Masukkan saja dalam the formula. Divide kan juga dengan vertical forces 461.235. Okay, kat sini vertical forces 461.235. Then this is the value. Jawapan ni memang daripada point B kat mana position dia daripada point B. Because kita nak tahu kat mana sebenarnya, adakah dia dalam middle third ataupun dah luar middle third, sebab kita nak kena kira ground bearing pressure ataupun base pressure. Daripada the retaining wall macam ni. Okay, so ini 3.6. You need to divide it by 3. Okay, kosong mesti dari B 1.2, 2.4, 3.6. You dapat 2.669, which means dia outside middle third because ini adalah inside middle third, right? So 2.669 ni dah outside, dekat sini lah lebih kurang Jadi 2.669 outside middle third. You know that the formula tu that you tak pakai macam formula example 7. Okay, because kat sini 3.6 lies within 1.2, 2.4. Resultant force RV cuts outside the middle third. This will not necessarily produce adverse consequences in reinforced concrete. And then soalan ni pun tak ada minta you nak kena check tension in the joints. Okay, but kalau dia minta means kalau dia dah outside middle third, dia akan ada tension in the joints Kalau dia inside middle third, dia tak ada tension in the joints. Daripada ni kita dah tahu dia outside. We know that the formula to calculate untuk dapatkan the ground bearing pressure, QA equal to, you ada dua formula tadi, you boleh pakai mana-mana formula, but here I pakai formula ni lah. Okay, 2V divide by 3 dalam kurungan B minus X. Masukkan saja value V. V ni adalah total vertical forces, which is 461.235. And then 3B, so B we know that this is the base width 3.6 meter, and minus dengan X, ambil je X daripada atas ni 2.669. Okay, and then you kira you dapat value like this. And since the question asks you to compare, which means you kena compare lah dengan allowable bearing pressure dalam soalan. Okay, here I dapat 330.279. Okay, you tengok kat sini dia bagi maximum base pressure should not exceed 100 kN per meter square. Kita dah dapat sampai 300 lebih dah. Okay, therefore it is not safe. Kalau less you dapat 90 something, it is safe lah. Okay, QB equal to 0. So kalau Q memang macam ni lah. So maksudnya ground bearing pressure ni dia macam ni sebenarnya. Okay, kat sini kosong. So kat sini it is 330.279. Very high Dia akan stop dekat sini. Dia ini in between dia yang besar. Ya, sorry, yang dia punya centroid So 330.279. QB kosong lah, kat sini value dia kosong. We need to check for overturning and juga sliding, because soalan dia minta factor of safety against overturning and factor of safety against sliding. So must be more than 2 and must be more than 2.5 for overturning, right? First, I check for overturning. Total stabilizing moment, total tolak dengan divide by total overturning moment. Masukkan je as what appear here. Stabilizing moment is 1000 blah 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 and overturning moment is 584 point blah blah blah. Masukkan this value inside here and you will get 1.734. Comparekan dengan factor of safety. Comparekan. Refer to question. So for overturning must be bigger than 2.5. However, here they less than 2.5. So it is also not safe. Wall ni akan overturn. And another one you must do for sliding. Okay, and then for sliding, however, inside this question dia tak ada bagi angle of wall friction. Kalau you check balik soalan ni, dia just bagi angle of shearing resistance 30 degrees, tak ada angle of wall friction. Kita assume angle of wall friction sama dengan angle of shearing resistance. Kita nak kira mu ni, you know that the formula is mu equal to tangent delta. So since kita dah assume dia sama, so tangent 30 darjah, you dapat 0.577, right? So ini adalah value mu. Masukkan, so 0.577. RV is total vertical forces. 461.235 ni as what you see in the formula, right? This one. And then divide with P. P tu adalah total horizontal forces, which is 216.513. Inilah dia. Okay. So you akan dapat value 1.229. And then again, you need to compare with the factor of safety given in the question. Dalam soalan ni, for sliding, dia kata factor of safety must be bigger than 2. Okay. However, here you dapat it is less than 2, which means it is not safe. Jadi semua fail.